Hi, my name's Don Brady. I'm with Clara Systems. And let's see, before I start, show of hands, how many people know what ztest is? How about ztest? How many of those people that raise their hands, how many use it regularly in their development? Okay, how many people wish they would have not opened the pull request with that embarrassing bug without testing it? Okay. So I'm going to talk about ztest and what it is, basically, and how it's different from this other tool we have called the ZFS Test Suite, and some of the benefits I've found, and go over a little bit of how you run it. And then there's this other tool, a companion to ztest called zloop. Show of hands, has anybody heard of zloop? Oh, pretty good. And then I'll talk about a feature that I just worked on recently where we added multiple pool support to ztest, and talk about some future improvements we can do. So what is ztest? I think a good way to summarize it, it's a generic stress tool for the ZFS code. It can test like how resilient is the code to like the changes I just made, and to combinations that you just don't think about normally. The tool is most of the ZFS code in the ZFS module compiled into a library that we can run in user space, and it interfaces directly with the ZFS portions of the code, like the SPA or the DMU. And we instantiate, when we start it up, we instantiate a mock kernel environment, if you will. So like all the kernel primitives, mutex, whatever, we use pthreads. There's a stub file called kernel.c that will put all what we're expecting from the kernel so that we can run it there. And then we use files for the VDEVs, the backing VDEVs, when we do the test. It's been available since the very beginning of ZFS. It was a great idea, great idea. Of course, great minds made ZFS, so it makes sense that they would have an awesome way to test it. As far as how it differs from the test suite, actually, how many people have used the ZFS test suite? Okay, yeah. So we have this test suite. It's a comprehensive, full stack, functional test of ZFS, and it runs most of the tests in isolation. It'll like be testing a specific part. Like I'm going to test zpull import for all these different flavors. It typically runs for 2, maybe 3 hours. I don't know, Brian. It's like 3 hours, but it doesn't do much integrity checking. It's like it'll run the test, and your test could have corrupted the pool, but it did what you tested it to do, and it just keeps moving on. On the flip side, ztest is very narrow in scope. It's testing the DMU layer of ZFS, the pool configuration layer, some of the zaps, the ZIL, the ARC, sort of the main core of ZFS. And the scope, of course, is to stress it out. We're going to try to break it, essentially. And the runtime is, by default, 5 minutes. You typically run it short burst. You can run it longer. The longer you run it, the greater the odds you're going to eventually find one of the unfixed bugs that are still in ZFS. And then finally, as far as integrity checking, it'll actually intentionally try to corrupt the pool. And then at the end of the session, or after it crashes, it will run ZDB. So it'll validate, all the checksums. It'll validate like the space map law, all the integrity of all the different components in ZFS. Check for leaks, whatnot. So it's good. It's good in that it'll break your code potentially, and then validate or validate that you didn't corrupt the pool. Again, the scope in this picture over here, there's like ZFS has an interface layer. It could be whether you're doing admin commands or POSIX commands. that whole way that you think of getting into the inside of the ZFS. We're not testing any of that. We're going to test basically the core functionality of ZFS. We don't cover, obviously we don't cover the SPL, the Z layer, we don't do ZVols, Z events, don't test send and receive, channel programs, and then the VDEV disk layer, we're not interfacing with the block layer or engaging any of the kernel in terms of the I/O that we're sending out. So why is it stressful? Well, we're going to do a lot of stuff in parallel. We're going to be creating and destroying data sets on the fly, while we're reading and writing to other data sets in the pool. We'll be constantly changing, the compression, what compression we're using, what checksum we're using, whether or not we have encryption. We'll hey, let's turn encryption on. Let's turn it off. Let's make use this checksum, and it's no, we'll switch it over to this one. All the while we're changing the pool configuration. Where hey, let's add a slog. Hey, let's remove a VDEV. Hey, let's do RAID Z expansion right now. It's so a lot of churn in these different layers. And all the while, it's changing data set properties. Hey, my record size is 4K. No, in the next second, it's 128K. So it'll pick, when you run it, by default, it'll pick a configuration. It'll like a mirror, a RAID Z, or DRAID, and the appropriate number of disk to run that config. And it'll spawn, in addition to the kernel context, which is going to have all your task queue threads, your transaction sync threads, all the threads that the kernel normally has. It's going to instantiate all those. On top of that, it's going to spawn 23 threads to go bang on ZFS. And then there's up to 7 data sets. Typically by default, you can put more in there. And currently, at last count, there was 38 individual tests that we're running. It'll pick a random test, run it, and then come back and do another test. And up to 5 top levels. So if it picks DRAID, it's going to test DRAID with one top level DRAID, and it's going to make another one. And it's really stress it out, because I don't know in real life if anybody's actually deployed 2 top level DRAIDs. But ztest will certainly do that. And as I mentioned earlier, it'll inject random garbage on some of the leafy devs to confirm that the self-healing works, and confirm that RAID Z construction works when one of the disk is damaged. I mentioned we run it in a process. So there's a main process when you run ztest. It'll spawn a new process, and that child process is simulating the kernel. And the advantage there is we can kill that process right in the middle, whatever it was doing. And so 70% of the time, it'll kill the process. What it does is it starts out with a 5-minute goal, and every 60 seconds, it'll either unmount the pool, remount it, and go do a new set of tests, or in that one segment, it'll just kill it. And so you'll see that in the summary. It's I like to think of it as everything, everywhere, all at once. Oops. This is where I think the internet went down. You see I go up, go down. Is the internet up? What's that? Oh, you mean go yeah, okay. No. Yep. Okay. Well, I want the slideshow to start there, so let me see. Well, let's see if we can bring up this. There we go. Okay. From current slide, I'm clicking you. Yeah, it's having trouble rendering it because it's. Yeah, this demonstrates the topic. Yeah. Wow, I've never seen it do that before. Okay, worst case, I can go back to PDFs, but okay. Anyway, the slide I wanted to show in the slideshow was everything, everywhere, all at once, and sort of summarizing what I was talking about. Okay, I think we're fine. So yeah, so it's banging on the disk. It's like has a number of data sets that it's just doing random things on, and all the time. So let's see if I can go back from here. Okay, well, let's do this. Sorry about that. I didn't have control. Send a slideshow. Okay, sorry about that. Note to self, don't use live internet for your slideshow, which was fortunate because I was hoping to do a live a demo later. But so as I was mentioning earlier, there's 38 tests. You can see here, I won't read them all, but there's like stuff that's gonna to hit the DMU. There's stuff that's gonna be doing SPA config, all those type of things. And then VDEVs, like we're gonna be doing all kinds of things that you wouldn't normally be doing on a live, like adding VDEVs while you're still writing to it. Typically, you quiesce your system and you add a VDEV or something like that. This is all going to be happening dynamically. We do a little bit of the ZIL and the ZAP, mostly just sort of in combination of other tests, but there's a little bit of coverage there. And then we're specifically testing some specific features like MMP or RAID-Z expansion or things like that. And this slide, I apologize, I don't know if anybody can see it other than me. Well, that part where it says calls into the SPA layer directly, I'll just read it. It's doing a SPA config enter, which if you're familiar with the SPA layer, that's the big global lock before you do anything. And then we're going to go find the top level VDEV. And then this is device removal. So I guess it passes in something. So, and then we're going to exit the lock. So we have our VDEV. It's been safely gotten. And then we're going to just call into SPA VDEV remove. And then we do some error checking. But so that most of the tests are similar to this. You get past a little bit of context. The ID is the thread ID. So you can, if you have, say, like your 7 data sets, you can, modulus that ID to pick a data set, basically, and then run your test. And most of them are like this, very short, very specific. But bear in mind, there's 20 other 3 threads. They're also running a test. So sometimes, like in this test, yeah, you can't see it. We take a VDEV lock because we know we're doing something with VDEVs, and so we sort of protect ourselves from doing too much damage. Yep.
I haven't used this live or anything, but if you have a environment where typical customers users saying that things are behaving slow, whether it's read or write. Is there a way, can you use ztest to kind of test that real time to kind of try to duplicate whatever they're saying? If they're saying, hey, we're having a bunch of read issues, and you can say, well, let me just run ztest for like 10 minutes and then see.
No, not really, because the randomness of it, it's not doing a
Okay.
specific workload. It's just doing sort of, there's some test that will do a bunch of writes and stuff like that. But it's good for testing out a config, and I'll get to that in a second. So like if you always do a certain raid z config, you can run ztest that way all the time. So whenever you make a change, what I do a lot of stuff with raid z, so every time I'm done touching my code, I'll go run ztest with a raid z config to make sure I didn't break anything. Of those tests, we'll run them with a frequency that's, whoever wrote the test, they can say, hey, I think this is very important. I want you to run this all the time. Or I recently added a test for pruning the DDT table, which is like, we don't need to test that often. So I put the rarely option. So, every 60 seconds, it might randomly choose that one. So for example, like the DME read write test, we run that all the time. That's just like running almost if you just did a profile, you would probably be running that test. On the other side, reGUID, that's not gonna break anything. It's a very simple test, so we just run that fairly infrequently. As I mentioned earlier, we do test integrity, and we intentionally write garbage on the disk. We do other things that we'd want to make sure that the integrity is correct. So that's covered by either on import we'll run ZDB, or we'll potentially kill the process. It should be safe. CFS is copy on write, and we'll verify that by running ZDB. So why would you want to use ztest? My thinking is, why wouldn't you be using ztest? But so first, as I alluded to earlier, it's like it'll find the bug you introduced. If you break CFS fundamentally, almost like when you run check style before you do your pull request, I think it's warranted to run ztest. It only takes 5 minutes. And it gives you confidence that you didn't, embarrassingly break CFS in a fundamental way. It's also good to exercise if you're changing code, the new code paths that you're working on. You want to get some exercise. You can run ztest. I often use it to test out some theories if I'm curious, like how a certain part of the ZFS code is working. I can put some printfs in there, or and then just fire it up, and I can see, as ztest is running, like what it's doing. It helps me understand how the code is working. Obviously, it'll help catch regressions. And then another benefit is that I'm not going to set up multi-host protection. I mean, that's just, I got to set up 2 servers, all this. Or same thing with DRAID. It's like, I don't have 20 disks laying around. But ztest will test that for you. And like gang blocking, some of these things where they don't normally come into play, it'll test that to make sure that it's working. Basically, to run it, you just type ztest. I'm intending to fix it. It used to be non-verbose if you didn't specify verbosity. Right now, you see a bunch of spurious stuff coming from the kernel that I like to know. But as far as ztest output, -v will give you some terse output, and more v's will give you like more and more information about what it's doing, what it's running. As I mentioned, you can test a specific config. So like in this example, I want to test RAID Z. I'll specify how many disks I want, how much parity I need, and the size of the disk. It will, right now it'll create 7 512 meg disk, but I didn't specify the top level, so it can make it would make up to 5 of the, so 35 disks could be made in the run of this test. And then this is just sort of a hand-picked, I don't know if you can see that either. It's coming out fluorescent over there, but at the end of the run, it'll tell you what pass it was, you know, whether or not it sig killed it, whether or not, how much space it's using, how much time is left on the clock. And so this is giving me a summary, and look, there's a bug. It says, in my 30 seconds that I ran, it said it ran 8 minutes and 26 seconds in DMU write parallel. That's not possible, so we'll have to go fix that. So zloop. You can run ztest. You can run it. You can specify a time for ztest, and it'll run, but it will only be running against whatever default config it picked. So if you want to run it for a long period of time, it's probably more advantageous to have it check multiple configs. So that's what zloop turns ztest into like a longer running test. And then the other thing is if ztest crashes, you ran it overnight, but it crashed, you know, after an hour. Well, you didn't get the benefit of a full night's worth of testing. So zloop will let it run. If it crashes, it archives off all the information, like all the log files and the vdevs and the core file, and then it runs it again. So you'll get the benefit of a long-running test overnight, which is when I usually run it, zloop, run it overnight, and you can come back and you have all this wealth of stuff to go debug after you run it. Here's a sort of an example, and again, I apologize you can't see that, but it'll summarize, when you run zloop, normally it'll just give you sort of a terse summary of what it did. In this first line, it picked DRAID, 27 disk, and then the DRAID, you know, the different, you know, 2 spares, 10 wide with the DRAID, parity 1. And then that test passed fine. Then we ran RAID Z, 9 disk, parity 3, and it crashed. And so then it archived the disk, all the information, and then it'll just run another test. If people are interested during the hackathon, I could do a ztest breakout with live debugging. If you ever open a pull request and it says zloop failed, you're like, and what do I do now? I can give you some tips on debugging that. At the end, maybe at the Q&A part, I don't want to risk going on the internet right now, but I'll walk through that later. So why not have more chaos in ztest? So we have customers that have multiple pools, and a lot of configs now have like an R pool and your data pool. So it makes sense that, hey, if you're going to stress it out, why not stress it out with multiple pools? So it was a great learning exercise of how ztest works, because I had to like go in there and figure out what it was doing before I made this change. But essentially, it's similar in function. So, but instead of each thread like saying, I'm going to hammer on this pool, on this data set, I'm going to hammer on this pool and these data sets. And I just arbitrarily said, like, the thread count is multiplied by the pool count. So then you're going to kind of get that same stress across multiple pools. Let's see. And then one thing that I added, which I think the default probably would benefit from, is sort of a check the space, because we provision these files with truncate, and so they're sparse. And so, like, yeah, your test is running fine, except all of a sudden your vdevs, you can't write to them because they get no space back. And I found some interesting crashes in ZFS proper, because it's like, it's not used to getting no space in the middle of trying to write to a disk. So I added that check. So when you say I'm going to run it with multiple pools, or even without multiple pools, but you're going to do a DRAID with 50 disks, it'll check, do you have enough space to do that before running the test? That's kind of a nice benefit. There's a few TBDs left on that pull request. Basically, I'm not testing import and export. I'm just doing the classic ztest test. So like ztest will open the pool or create a pool at the start of the run, but then it doesn't like export, import. So we have parallel imports, parallel exports now. So it'd be good to just sort of also have a new test that will export and import. And then as far as logging goes, it's confusing without multiple pools because it's just spewing stuff. And so with multiple pools, it's like, what do we want to do? I thought we could either tag the lines or maybe even better, have separate logs for each pool. Because when you have to come back and debug, it's like you got to find sort of the needle in the haystack of what went wrong. So there's a pull request open upstream. I'd like to hopefully get some reviewers on that. I think it's a great addition to finding more bugs. I found several already, and so it's kind of a nice thing. And so here's a run and that you can't see. Well, I don't know. Probably can't see that. So it's the same thing, except now in the summary, instead of just saying I have this pool, how many spaces I got out of it, how much I'm using, I added. You can see the summary. So like in this case, I was running it with RAID-Z with 6 disks, parity 1. And then the first pool has 18 disks because, well, they decided to make new top levels a couple times. And there's another one with 12. And so you can see that it's like the tests themselves have variance, and that's going to show up when you run it against multiple pools. Any questions on the multiple pool stuff? As far as future for ztest, as I mentioned at the start, there's a lot of things we don't test, so we could potentially add more stuff. One thing that might make sense is Z itself is a user process, so why not spin up Z and have a way to test Z in the mix. Another interesting issue is that when you run ztest, it's going to pick things at random. What's the A shift? It's going to be 9, it's going to be 12. What config I'm going to use and what test I'm running. And so if you get a bug and it crashes, even if you fix the bug, when you run it again, it's not going to run that same test. And so you just have to run it a whole bunch of times and hope that you covered it. So my thinking was we could do like a seed or something to guarantee sort of the same run, so that if you do get one of those outputs from zloop, you can just keep running that until you resolve the problem. Another thing, it doesn't test with larger metaslabs, larger blocks, things like that, mainly because it's constrained in terms of you have to have space and memory to do that kind of stuff. But if you had memory, it'd be nice to be able to say, like, I want to see how it works with big blocks. And so you could, if you had the space, allowing it to do that would be nice. Memory management, I mentioned earlier that we just compiled a kernel it's like a mock kernel. So instead of calling kmem_malloc, we just call malloc. But also, instead of calling kmem, on Linux at least, instead of calling kmem cache free, we just call free. And so you could actually allocate something from one kmem cache, free it to another, and ztest wouldn't catch that. So it'd be nice if ztest was backed by similar to what we had on Illumos was this libumem, where it actually has real kmem caches, and probably have additional testing for double freeze, things like that. You can run it with Valgrind or other memory allocators that interject, but it'd be nice to have that sort of baked in, so we're getting that coverage. And I thought, well, send and receive. We have data sets. We could send them internally, so that might be another test. And this is where if people have ideas or something they just like, oh, I wish it did this, this would be a good time to let us know. We could bring it up in the QA, but okay.
What I wonder about is, can we test combinations of feature flags? Like right now, I'm assuming it's the default of every feature flag enabled, but ztest randomly disabling feature flags at create time sometimes.
Yeah,
and
what it
seeing
does,
how that
yeah, right
interacts.
now they're all enabled, but it opts 50% of the time it'll test space map logs. 50% of the time it won't. And so other features like that, it'll toss a coin. So you get the coverage. I think same thing for the new dedo. Like
Right, but
one run will do the old one will do the new one.
maybe some percent of the time we could set a feature to disabled and make sure things still work.
That's a good idea. We don't test feature flags essentially, but that.
Well, especially with the compat equal stuff that we have now, not everybody's actually upgrading their pool to have every feature enabled anymore. And we want to make sure that we're not, missing something because all of our testing assumes that every feature is enabled.
Yeah, that's a good point, because right now it'll like whatever you compiled, the latest, master, it'll like just run with all those on, except, like I said, like some of the tests features it'll disable intentionally, but most of them are on. So it might be good to work that in there.
Yeah, I wonder about maybe we pick a subset of tunables to start frobbing as well as part of the testing to see what happens if we, change the amount of aggregation that's allowed, or a couple of the other ones that might actually impact what it's doing.
Yeah, I didn't mention it, but you can, any global, you can override the global in the command line with the -O, I think.
Yep.
But.
And with your idea for the repeat log, would we be able to do something like, if this z-test fails, can we run that one again and like see if we run it 3 times, does that same test fail consistently, or is it only failing some of the time? And
yeah, I think if we spit out the seed or something like that, we could run it again.
Yeah, actually have the CI.
What's that?
Have the CI help us determine if this is like a occasional failure, or if this one fails every time, so that much less work that the developer has to do when they're investigating the CI failure.
I'm thinking like that's a good idea. Maybe Z-loop, when it fails, it should run it again.
Rerun that same test again, exactly.
And see if it can diverge onto, oh, I ran it 3 times and it failed. Like this is really a bug versus, we see failures that we'll never see again. Yeah. Yeah, that's what I was hoping, because it's just tossing the coin every here and there. So if we could have all the coin tosses be the same, then we have better odds of reproducing it. Yeah. Yeah, that's probably and if people are interested in doing that in the hackathon, I'd be happy to participate in that.
Is there an upper limit on number of tools for the multi-tool test?
Memory.
Repeat the question.
Yeah, the question is there an upper limit on the number of pools you can test with? Yeah, it's basically disk space. So when you type in the N and your config, it'll make sure that there's that much free space in the directory you told me. And if there is, it'll run, yeah. So there's no limit, yeah. It's like if you have a terabyte of RAM, you can really go to town. Other ideas of things people would like to see in ztest? Is anybody interested in send-receive testing in ztest? Okay.
What about encryption?
It tests encryption, but I mean, it just turns it on, and so if you're running the code pass, but are you thinking of more?
Back into your send receive, and it's one of the conversations we had earlier, was if you send something that's encrypted, receive unencrypted, that whole process, that's...
Oh, yeah, like a raw receive.
That 6 mesh possibility of how to actually receive things.
That's a good point, yeah. Other ones?
I'm curious if there's any in the development of all the fast dedupe code that you guys have developed, did this I imagine ztest found some interesting things. Any stories from any of those test runs? Found something crucial?
Well, it's hard to say because I'm always finding stuff in there.
Yeah. Okay.
But as far as dedupe goes, we do this. Let's see. There's pruning, and then there's what's the other thing? I think it's the prune. Yeah, the pruning. The pruning is interesting because it's like, how do you prune? How do you know what's old and all that? So we keep a histogram, but that's all like hidden magic in there. So what I did for ztest, it actually prints out the histogram and shows you like how it came about of choosing, what it's gonna eject. So things like that. That's a good use of ztest. You can actually run the test, but not have to like recompile the kernel with special flags to generate the histogram and all that kind of stuff. So cool. So how can you help out the community here? I would suggest, and I don't know if I convinced you, but just to use it in your day-to-day development of ZFS. It's so easy to run. You can just run it. You can run it off on the side while you're doing other stuff, and it does find bugs. And then if you're going to add a new feature, to the extent it's in that SPA, DMU sort of core part of ZFS, I'd recommend adding a test. It'll exercise your code. And then if you find a bug in ztest, like in your development, I'm changing this, but every time I run ztest, it keeps finding this, like open an issue so that we can go, someone in the community can know about it and go chase it down. Because often, with the randomness, how much memory you have, your CPU speed, all these variances, you get different behavior. So some people on their machine, I've seen people have machines that will reproduce a problem, and then I'm going on my machine, I cannot reproduce your problem. And they swear that it's like 100%. So if you can file issues, that'll be helpful. And if you're willing, help us chase some of these down. I know, thank you, Paul. Paul's been doing it. I see occasionally Paul in there chasing down a bug, because it's annoying when you're trying to do your work and you keep tripping over these bugs. I know when I was finishing up RAID Z expansion, I kept running it and I was trying to chase down a few known RAID Z expansion bugs, but I kept encountering all these other ones. So it's nice to get those out of the noise. Ideally, zloop and ztest would run with no issues. That would be the goal. And then we can have high confidence that if it does break, we broke it, basically. Any other questions?
So this is not specifically about ztest, although ztest is a part of it, but it's about sort of like the code base in general and quality and passing tests. I feel like over the years there have been a few features that have managed to integrate with testing problems. One of them that caused pain for quite a while was hole birth in ZFS send and receive, where we tried to omit sending holes and then lost birth time information and caused some data corruption in a few cases. Encryption's another one where there are still a bunch of lurking issues with encryption, especially around send receive, but also in general. It feels like we need to have a conversation at some point about how to actually ensure that ZFS is consistently like passing tests and resolving the bugs that we find, and like that you can run ztest for 24 hours without hitting an issue, and that there aren't known failures in the test suite that could be masking serious bugs. And like how we try to ensure that ZFS stays a best-in-class file system and like stays reliable and performant and does not lose people's data. And so I think encouraging people to use ztest is a good part of that, but I think we also should have a conversation as a community about like standards for testing and standards for like defects and things like that in new code and in existing code.
Yeah, that'd be a good conversation to have with Brian or Tony maybe, but yeah, right now I don't know what the threshold is for like, zloop has sort of random failures in there, so do we not require it, or we just say run it? If you run it again, you're going to get a different answer. So
I think that's the problem. Like, so yeah, it's a fantastic tool, but it's been neglected, And so over the course of years, you know, it would fail, and then we just didn't, nobody was really looking at it, so it got ignored. Where like the ZFS test suite, I think probably got more weight just because it's testing that specific functionality, and ztest being more of a stressor. But it does require us to like kind of spend some time and be like, okay, maybe it's time to go back and invest in it some more so that we can trust it. Because I think that's where it's lost favor, you know, amongst developers, is that it's really good at certain things, but oftentimes it crashes, and you're like, it's crashing in code that isn't mine, and I don't have time to go, you know, spending time looking at it. But I think we need to Paul's point.
While I'm waiting for the next question, I'm just going to bring up the web page for the GitHub for ZFS. If you go to the actions page, off to the left, you can see zloop there. And this is all, oh, look at that. Somebody broke ztest. So, sorry, Alexander, looks like ztest had an issue. So you can click on the Z loop here, and then you can see, well, I don't know, the internet's going to work here, but I'll just try it. Okay, so this tells me what it was doing. It was running a RAID Z test when it failed, and then for some reason it didn't dump a core, so I don't know. This one's a little trickier. Often, if you go to the GDB log, it'll show you the backtrace of like what crashed, and that's useful. Sometimes ZDB will crash. That's a problem. Let's see if ZDB crashed. Oh. ZDB was busy. ZDB didn't crash. So yeah, this one's a mystery, but often, like if ZDB crashes, then you can just take those VDEVs and run it again until you solve the problem. That's the one nice thing about a ZDB crash here. A ztest, you can run it again and get completely different coin tosses, and then you're not testing the same exact thing. But sometimes, I've found more often than not, if I just rerun, it'll crash again because I broke something fundamental, and it's like, it's going to tell me. So. Other questions? All right, I'll be available up here if people want to talk about it. And then, like I said, tomorrow, if people would like sort of a hands-on debugging ztest and or zloop, I'll be available for that. Or if someone wants to hack on adding send and receive or some other missing part of ztest, I'd be happy to help out there as well. All right, thank you.